Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll explain how to examine correlations with scatter plots. Scatter plots are a good way to visually examine the correlation between two variables. Remember from class that a scatter plot is a graph in which pairs of scores are plotted. The scatter plot shows us the bivariate distribution of scores. Recall that each person has two scores, one for variable x and one for variable y. That's a pair of scores for each person. We can depict these scores using the scatter plot by plotting people's two scores using one dot placed between the two axes. We plot the x variable on the horizontal axis and the y variable on the vertical axis. Let's go over an example with actual variables. Here, loneliness is the x variable and depression is the y variable. If we're plotting the bivariate distribution of loneliness and depression, I will plot each person's scores using the two axes. If person A, the pink arrow, has a loneliness score of 91 and a depression score of 0.18, I draw the dot here for person A. If person B, the purple arrow, has a loneliness score of 100 and a depression score of 0.8, I draw the dot indicated for person B. Let's take a look at what different relations might look like on a scatter plot. Here's an example of what a scatter plot might look like for a positive association. Generally, the low scores correspond with the low x scores correspond with low y scores. In addition, the high x scores correspond with high y scores. If we drew a line through these, it goes from low to high. Here's an example of what a scatter plot for a negative association might look like. Generally, the low scores correspond with the low x scores correspond with high y scores. In addition, the high x scores correspond with low y scores. If we drew a line through these dots, it would go from high to low. Now let's look at some scatter plots that depict strength of relation. Here's an example of a perfect relation. There is perfect correspondence between variable x and variable y. If we know a person's score on x, this means we could know their score on y too, because the relation is perfect. The correlation coefficient for this plot would be positive 1. It's a perfect relation, which is the strongest relation we can have, so the coefficient is 1, the maximum. It's positive in direction, so low scores on x go with low scores on y, and high scores on x go with high scores on y. Here is another example of a perfect relation. There's perfect correspondence again between variable x and variable y. If we know a person's score on x, we know their score on y too. The correlation coefficient for this plot would be negative 1. Again, it's a perfect relation, the strongest relation we can have. So the coefficient is 1, the maximum absolute value, and negative. Negative in direction means that the low scores on x go with the high scores on y, and the high scores on x go with the low scores on y. You can also have a non-perfect relationship. You can still see a pattern of a linear relation. For example, if it's a positive non-perfect relation, most of the low values on x correspond with low values of y, and most of the high x's are with high y's. However, the relation is not perfect, and it doesn't form a totally straight line. Here's an example of a non-perfect relation. You can see here that there is some sort of relation in the positive direction. Most of the low scores on x are with low scores on y, and most of the high scores on x are with high scores on y. But it's not a perfect straight line. If you knew someone's x score, could you tell me with certainty what their y score is? No, we couldn't, because the relation isn't perfect. We might be in the ballpark guessing, but there would be some error. And you can have a non-perfect negative relation as well. This is a non-perfect positive relation. There's also the case of having no relationship. This means there's not a linear relation. High scores on one variable are just as likely to be associated with high scores as they are to low scores on the other variable. Similarly, low scores on one variable are just as likely to be associated with high scores as they are to low scores on the other variable. Data points may seem to be randomly scattered, as if you took a pepper shaker and just shook pepper onto your scatter plot. Alternatively, you may see a pattern, but not a linear one. This would give you a correlation coefficient that's close to 0 or exactly 0. Here's an example of what that might look like. You can't see a pattern here. There's no evidence of a linear relation. The correlation coefficient would be 0 or very close to 0. Knowing a person's score on X gives you no information about his or her Y score. This concludes the second lecture on correlations. In the next lecture, I'll show you the formulas for calculating a correlation and describe other types of correlations.